So another thing that stems from using compound interest is a future is a situation called present value. And basically, if we know there's a certain future amount we want to achieve from the result of me taking some set amount of money and applying compound interest to it, and I know what my final outcome to be, then I can determine how much money I need to invest right now to make that happen. The way your textbook presents it, and I'm going to kind of show it, is that they make it sound like you need a totally different formula to do this, and that's not the case at all. Um, so here, I mean, they're kind of going through this and they're making it much more complicated, I think, than it needs to be. And they give you this separate formula. And you can see it has some of the same parts as the formula we had before, which was, of course, I gotta get it, which was, our A equals P times 1 plus R over M to the MT power. You can see some of the same aspects to it. I see P, I see the 1 plus R over M and the MT power. I see a lot of the same thing. What's different, though, P here isn't basically representing the principal here. It's representing the future amount of money. And that's one of the things I don't like about, some of the things that they choose to do is because of the fact that they're changing they're changing the meaning of variables along the way, which makes it all the more difficult to know what you're doing in the various circumstances. But to do present value problems, all I'm telling you, all you really need to do is just have this. Now let me show you how the textbook handles it, and then let me show you something about, this formula versus, the formula for present value here versus the formula we have here for compound interest. So for the example that the textbook gives, they say find the present value of $5,000 to be paid 8 years from now at 10% interest compounded semi-annually. So basically, we want to be able to make a $5,000 payment 8 years from now. Knowing the fact that I'm going to put this money somewhere so that 8 years from now it's going to be at $5,000. So we're looking for how much money that's going to need to be if that interest is 10% interest compounded semi-annually. So they use the formula, of course, where we want P to be our future value. It's not the principal anymore, it's the future value. R is 0.10, M is 2, and of course T is 8. Now, I mean, the one good thing about it, I mean, if you use this formula the way it is, I mean, you're still doing a plug and chug problem. But the thing is, I mean, we learned algebra for a reason. But if I calculate this, I get about $2,290.56. So if I want, $5,000 8 years from now, given that I'm investing it in an account that has 10% interest compounded semi-annually, I need to start off this account with $2,290.56. Now, again, as I said before, they make it look like you have to know an entirely different formula altogether. I'm saying if we just start with this formula here, well, where A represents the future and P represents the present amount, which is basically the present value. See, now in the formula they have above, P doesn't stand for the present value. It stands for the future amount, which, gets confusing. But, if I'm using the formula that we did before, those what they represent. If I wanted to solve this for P, the present value, I would divide both sides by all of this thing, because all this would be is a number when I'm done calculating it. So if I divide both sides by that, of course, these will eventually cancel, and I'm left with the exact same formula that we have up there. The only thing that's different is I have this being the future amount. That's why I think it's important for you to notice this, is because the way your textbook has you approach many things is like, well, here's another formula to know, here's another formula to know, here's another formula to know. Meanwhile, they're all the same formula. All we just shown here is that this present value formula is simply an algebraic manipulation of the compound interest formula. That's all it is. So either you could use this formula, to memorize it and plug the numbers in for the next problem I'm going to have you try, or you could use the fact that all you do is set up your compound interest formula. The only thing that's going to be different is you're going to know the final amount and not going to know the principal, and then you're going to solve for the principal. So with that in mind, let me give you a moment or two to try this problem here. So the problem reads, the cost of a 4-year private college education after financial aid has been estimated to be $50,000. How large a trust fund paying 6% interest compounded quarterly must be established at a child's birth to ensure sufficient funds at age 18? So basically, when this kid reaches 18, we want there to be $50,000 in this trust fund. So we want to make sure that we're putting it into this account, we're investing it, but how much do we need to start it with to make sure it's up to that amount? So now you're going to see here, I don't use that formula. I don't use the present value formula. I simply use the compound interest formula. That's all. All that present value formula is just an algebraic manipulation of this one. The other thing I have to make sure I'm aware of is that I don't want the starting amount to be $50,000. I want the end amount to be $50,000. Everything else goes in the same place. The 6% becomes the 0.06. The fact that it's compounded quarterly means I have 4 yearly compounding periods. And 18 is the time, which represents the time in years. So if I simplify this a little bit, 1 plus 0.06 over 4 becomes 1.015. 4 times 18 becomes 72. Now 1.015 to the 72nd power is just a number. So I'm going to take that number and take 5,000 and divide it by that number on both sides. So I'm left with P, which is going to be the present value in this case, equaling 50,000 divided by 1.015 to the 72nd power. And when I work that out, I get that the present value that I have to invest in this trust fund now has to be about $17,116.50. If you have any further questions, please ask about it in class. Until then, go on to the next example, and have a good day.